This video instruction is for the Cleaver-Brooks Clearfire W boiler quiz. It will show up Monday morning, February 22nd at 6 a.m. On the wiring diagrams tab here, when you click on it, you will see underneath the Bryan Triple Flex boiler, here's the Cleaver-Brooks Clearfire W, and you click on that. Here is the complete operation manual, O&M manual, for the CFW or Clearfire W style boiler. There's 278 pages. I don't expect you to read all 278 pages to do the quiz, but it's there for your reference, and you'll see that it opens up in a separate tab. Go back to the main diagram page, and here is a complete boiler diagram. This is actually right out of that manual that we just looked at. It's page 2-13. A lot going on there, but you'll see that what they call their Falcon control here is the exact same thing as what we went through with the Bryan Triple Flex boiler controller. So I wanted to make a video or a quiz that will accompany this video that will kind of test what you remember from the Triple Flex boiler. But let's say last week you worked on a Bryan Triple Flex boiler, and this week you're going to work on a Cleaver-Brooks Clearfire boiler, and you get to the Cleaver-Brooks boiler and you start looking at the wiring diagram and information, and you think, well, this looks a lot like the one I just worked on. And you know, both manufacturers use the Honeywell Sola R7910 controller, so yeah, they have different trade names for it, but it's basically the same controller. So here is the complete diagram page. I'll go back, and here is the expanded diagram. I zoomed in on it so we can see a little bit better things like the blower motor fuse selection, depending on the CFW size, the Clearfire W size, whether it's a 400 up to a 2400. You know, you've got different fuse ratings because obviously this blower is going to be a different horsepower, require a different fuse. So this blower fuse right here, depending on the model number. And one thing you'll notice different from the Triple Flex boiler is that this blower is actually a 115 volt single phase blower. Still has the DC control connector coming from J2 right here. This is what sends the pulse width modulation signal to the blower to tell it how fast or slow to go. Really the only difference is that it's 110 volt. You can see here that it specifies that the wire gauge for the blower wiring has to be 14 gauge. Here is a on-off switch for the combustion blower, but you'll see this is actually a 2-pole switch. It has a pole here that controls the 120 volt going to the blower, and it has a pole right here that controls the 120 volt going to terminal number 5. One thing about Cleaver-Brooks, and I'm not really sure why, but you know, on almost all their wiring diagrams, you'll find that L1 or 120 volt power is going to be terminal number 5, and neutral will always be terminal number 4. That's just a common thing for them. Instead of using any other terminal designations, they typically use 5 for L1 and 4 for common. Okay, a few things just to go over on the diagram here. I've already made the quiz up, so I know exactly what you'll need to look at on this diagram to complete the quiz. But you know, I want you to look at this as, you know, you already have prior knowledge of how this controller operates. So the questions that I'm going to ask on the quiz, you know, are specific to this diagram. One of them will be right here, this ionization electrode, and it says burner canister ground. Well, this is a flame rod, and a flame rod works on the theory of ionization or passing current through a flame. Someday, hopefully you'll be in my class and I will show you what I think is the oldest functioning flame safeguard in the world. And I say that because I have it, and it was manufactured back in the 1940s, and it uses this technology of ionization for the flame rod, something I think is pretty cool, but it's fairly common. Um, Here is the ignition transformer. Here's the ignition electrodes. So you have a flame rod and then you have ignition electrodes. You can see here where it says reference 14. Here's terminal number 2. These square terminals, when you scroll all the way down to the bottom of the diagram, the square terminal denotes that it's a control panel terminal, which means that there's going to be a terminal strip in the control panel, and that's terminal number 2. But where it says reference 14, you look over here on the far left and you'll see that there's reference numbers. And here is reference 14, reference line 14. You follow it over. Here, in fact, is control panel terminal number 2. It's for external ignition. So on J5, there's J5, telling you what this strip right here is. Here is J5 terminal number 4 is wired out to control panel terminal number 2, and that is for external ignition. And sure enough, that is the 120 volt power that goes to the ignition transformer. Here is the 24 volt transformer. You know that from prior knowledge of the triple flex controller, that terminals 1 and 2 right here on J8 get 24 volt power. There's your 24 volt transformer. And you know, because I just told you, that terminals 5 and 4 on Cleaver Brooks control panel terminals is typically 120 volts. And sure enough, that is a 120 to 24 volt step down transformer. Here's your demand switch. And if you remember on the triple flex boiler, if you got 24 volts fed into terminal number 3 here on J8, that was the remote start. So here's the demand. It's either remote, off, or local. This is a 3-position switch. It can have an off position. That connector there can be right in the center if you turn it to off, and it will not run in remote or local if you have it turned off. So there's your remote, your demand switch with remote off and local position. It also transfers another contact down here, and I think you'll see there's another contact for this switch. That switch has multiple poles. This switch right here is just 2 pole right here, and right here the power switch. Looking here, I did put some questions on the quiz regarding these relay contacts. Now, inside the Falcon controller, these are dry contacts, which means that they are not powered by anything inside the controller. They are just a switch connection that you can power. So here we got terminal number 5, which 120 volt power comes in on J4 terminal 7, makes a contact here which sends out that 120 volt power out to terminal number 28. And there is a question on the quiz about terminal number 28. If you was to scroll all the way down here, you would see that terminal 28 powers control relay 2. And right here is the contact for control relay 2. And the contacts for control relay 2 are designed to send signal or power to the FAD, which is the fresh air damper. You know that because looking right here, it says fresh air damper. So this is the control for the fresh air damper or the combustion air damper. It can be, the fresh air damper can be 120 volt up to 10 amps. That's what rating you can run through that contact. And I wanted to show you on the fresh air damper, because I know this is on the quiz, that even though you send power to the fresh air damper, you really don't know that it's open until it makes a end switch or a switch inside the damper, or actually a physical switch on the damper. And that would be tied in right here on 13 and 14 of the control panel terminals. And you would definitely remove the jumper, and that would be your proof that the damper is open. And you can see that that power comes down and goes to your LCI. If you remember what LCI is, you will need to remember what LCI is, because that's another question that's on the quiz, probably the same question as before. Here is the low water cutoff. This is a different brand of low water cutoff. I can tell by the terminal designations that this is actually a Warwick. And if you want to look that up, it's WARRICK. They make a low water cutoff that's electronic, has a remote probe, and I know that their terminals that they use are different numbers than what the one you saw on the Bryan Triple Flex, which was the McDonnell Miller. Warwick is a different brand. So getting down to the bottom of the diagram, you'll see here there's indicator lamps. These are the symbols for indicator lamps. This would be a white indicator lamp. This would be a green indicator lamp, red indicator lamp, showing whether demand is on or off, showing whether the fuel valve is open or closed. And you'll see where it says reference 14. That means you need to go up to line 14 and scroll across here. There's terminal number 3, fed from J52. Terminal number 3, fuel valve. So that would tell you that the fuel valve is opened anytime you got power on terminal number 3 there. The alarm, there is an alarm indicator lamp, there is an alarm horn, and there is an alarm relay. So CR1 is energized anytime that there's an alarm condition, and here is a dry set of contacts that you use for your remote alarm indication. This is a contact closure that you can use for whatever you need in the way of remote alarm. Actually, there's two different places, 19 to 20 and 21 to 22. These numbers here, if you were looking at the plug-in relay, the plug-in relay would have terminals 11 and 14 and 21 and 24. But they wire that out or connect it to control panel terminals. So those are your two remote. So I think we're down to a couple things here. This is PS. If you look here, there's 120 volts coming down here, neutral L1 and ground, and it has a 12 volt DC output. This is the power supply for the system display. This is the touchscreen display. I don't remember seeing this on the the Bryan Triple Flex, but obviously here on the Cleaver Brooks boiler, they do have a power supply. It takes 120 volt AC and puts out 12 volt DC to power the system display or the touchscreen display. And last thing I want to go over is right here, you know, on the remote off local switch, there had to be a way of turning it on remotely. Here is the remote on off terminals right here. So you're ready to take the quiz. This will probably be the only quiz on this, but hopefully this helps. You know a little bit about the Bryan Triple Flex boiler and how the controller for it works. You see the exact same thing on a Cleaver Brooks Clearfire boiler with their Falcon system. You know, about the same thing. There's your sensors. All that looks very common. So hopefully this is an easy quiz for you.